Welcome to DC Digital Learning Session. I am Dr. Shobhan Kumar, working as Assistant Professor in the Department of Mathematics, Maharani Science College for Women. Today we have to discuss numerical differentiation. The process of computing the value of derivative dy by dx for some particular value of x from the given data when the actual form of the function is not known is called numerical differentiation. As regards the choice of a suitable interpolation formula, when the values of the argument are equally spaced and we have to find the derivative for some given lying near the beginning of the table, we can represent the function by Newton-Gregory forward interpolation formula when the value of dy by dx is required at a point near the end of the table. We use Newton-Gregory backward interpolation formula. From Newton forward interpolation formula, we have y is equal to y naught plus p into delta y naught plus p into p minus 1 by 2 factorial delta 2 y naught plus p into p minus 1 into p minus 2 by 3 factorial delta 3 y naught and so on. Here delta y naught, delta 2 y naught, delta 3 y naught are all leading forward differences, where p is equal to x minus x naught by h. P is equal to x minus x naught by h. Differentiating 1 with respect to p, now differentiating this with respect to p, we get dy by dp is equal to y naught is the numerical value. This is independent of p. Here differentiating with respect to p, dp by dp is 1, remaining delta y naught, plus differentiating p into p minus 1. It can be written as p square minus p after differentiating 2p minus 1 divided by 2 factorial delta 2 y naught plus first simplify it and then differentiate. We get 3p square minus 6p plus 2 divided by 3 factorial delta 3 y naught and so on. Call it as 3. Now differentiating 2, this one, differentiating 2 with respect to p, we get dp by dx is equal to 1 by h. 1 by h. It becomes, because here with respect to x means x naught is a numerical value, constant. Here dx by dx is 1, 1 minus 0 by h, it becomes 1 by h. Call it as 4. We have dy by dx is equal to dy by dt into dp by dx. Here we know that dy by dp, dy by dp, dy by dp. Substitute for dy by dp and dp by dx. We get here dp by dx is there, dp by dx, here dp by dx. This is a dy by dp. Substitute here, we get dy by dp is equal to 1 by h into 1 by h into, here from equation 3, this is a dy by dp, 1 by h into delta y naught plus 2p minus 1 by 2 factorial delta 2 y naught plus 3p square minus 6p plus 2 divided by 3 factorial delta 3 y naught and so on. Now this with the dy by dx becomes that x equal to x naught, x equal to x naught and p is equal to 0, then above equation becomes 1 by h delta y naught minus 1 by 2 delta 2 y naught plus 1 by 3 delta 3 y naught minus 1 by 4 delta 4 y naught plus and so on. This is the derivative of y with respect to x when x are equally spaced. And again differentiate this with respect to x. We get second derivative. We get second derivative is d2y by dx square is equal to 1 by h into 2 by 2 factorial del square y naught minus 6p minus 6 by 3 factorial delta 3 y naught minus 12p square minus 36p plus 22 all divided by 4 factorial delta 4 y naught plus and so on into 1 by h, and again here dy by dx. By back substitute, by taking p is equal to 0 at x equal to x naught, above expression becomes delta 2 d square y by dx square at x equal to x naught. It becomes 1 by h into 1 by s 1 by h square del square y naught minus delta 3 y naught plus 11 by 12 delta 4 y naught plus and so on. This is second derivative of y with respect to x at x is equal to x naught according to Newton forward interpolation formula. Another way is here by using given data, first we have to find the polynomial of x is nothing but y, and then directly differentiate with respect to x, we get dy by dx, and again differentiate dy by dx, we get d to y by dx square. That is also correct. Derivatives using backward interpolation formula. Newton-Gregory backward interpolation formula is given by y is equal to yn plus p into nabla y naught plus p into p plus 1 divided by 2 factorial nabla square yn plus p into p plus 1 into p plus 2 divided by 3 factorial nabla 3 yn plus and so on. Since p is equal to x minus xn by h, call it as 2. Now differentiating 1 and differentiating 2. Here differentiating 1 with respect to p and differentiating 2 with respect to x, we get dy by dx is equal to here. Differentiating this with respect to p, we get to dy by dp. Dy by dp, and this with respect to x, dp by dx. Substitute here, we get 1 by h into nabla yn plus 2p plus 1 by 2 factorial nabla square yn plus 3p square plus 6p plus 2 divided by 3 factorial nabla 3yn plus and so on. At x is equal to xn and put p is equal to 0 in this expression, we have 1 by h is equal to nabla yn plus here p is equal to 0, 1 by 2 factorial is 2 nabla square yn plus 1 by 3 into nabla cube yn plus 1 by 4 nabla 4 yn plus 1 by 5 nabla 5 yn plus and so on. This is the first derivative at x is equal to xn according to Newton backward interpolation formula. Again differentiating 1 with respect to x, we get d square y by dx square is equal to 1 by h into nabla square yn plus 6p plus 6 all divided by 3 factorial del nabla cube yn plus 6p square plus 18p plus 11 by 12 nabla 4 yn plus and so on. Now by taking p is equal to 0, we get d square y by dx square is equal to 1 by h square into nabla square yn plus nabla cube yn plus 11 by 12 nabla 4 yn plus 5 by 6 nabla 5 yn and so on. This is the second derivative of y with respect to x in backward interpolation form. Now I have to discuss some problems regarding forward and backward. Find dy by dx and d2y by dx square at x is equal to 1 for the following data. Here data is given, here x are equally spaced and corresponding y is also given. Y is equal to 1, 8, 27, 64, 125, 216. Here step length is 1. 1 is the step length and x naught is 1. Note down x naught and h. Now construct forward difference table. Here arguments and entries. These are the leading differences. Delta y naught, delta 2 y naught, delta 3 y naught, delta 4 y naught, delta 5 y naught is also 0. Now forward difference formula. From forward difference interpolation, we have dy by dx at x equal to x naught is equal to 1 by h delta y naught minus 1 by 2 delta 2 y naught plus 1 by 3 delta 3 y naught minus 1 by 4 delta 4 y naught plus minus and so on. And so on. Here at x equal to x1, at x is equal to x1, at x is equal to x1, at x equal to x1, and h is 1 by 1 delta y naught from the table. Delta y naught is 7 minus 1 by 2 delta 2 y naught is 12 plus 1 by 3 delta 3 y naught is 6 and remainings are 0. Therefore here x equal to 1. X naught is 1 from the table. Here we put x naught value x equal to 1 and all the values of delta y naught, delta 2 y naught, delta 3 y naught, delta 4 y naught, and simplify, we get 3. Therefore, derivative of y at x is equal to x naught is 3. And delta 2y divided by delta x square at x equal to x naught is equal to 1 by h square del square y naught minus del cube y naught plus 11 by 12 del 4 y naught plus minus and so on. But x is equal to 1 because x naught is 1 and h is 1 and del square y naught is 12 and remaining leading forward differences are 0, del 4 y naught 0, del 3 y naught is 6. Therefore, here del 2 y naught is 12 and del 3 y naught is 6 and del 4 y naught is 0. Therefore, d square y by dx square at x equal to 1 is 6. Therefore, dy by dx at x equal to 1 is 3 and d2y by dx square at x is equal to 1 is 6. Now another example is find dy by dx and d2y by dx square at x equal to 0 because here x naught is 0 for the following data. Here h is 1, x naught is 0. First construct a different table x and y. Here these are the leading entries, leading forward differences. Now using Newton forward formula for numerical differentiation, dy by dx at x equal to x naught 1 by h delta y naught minus 1 by 2 del square y naught plus 1 by 3 del cube y naught minus 1 by 4 del 4 y naught plus 1 by 5 del 5 y naught minus plus and so on. Here x naught is 1, therefore put x equal to x naught is 1, that is equal to h is 1 by 1, delta y naught is 4 minus 1 by 2, del square y naught is 3, plus 1 by 3, del cube y naught is minus 18, minus 1 by 4, del 4 y naught is 40, plus 1 by 5, del 5 y naught is minus 72. Substitute and simplify, we get dy by dx at x equal to x naught is minus 27.9. Similarly, d square y by dx square at x equal to x naught is 1 by x square del square y naught minus del cube y naught plus 11 by 12 del 4 y naught minus 5 by 6 del 5 y naught and so on. We know that all the values substitute and simplify, we get 117.6667. Therefore, dy by dx is equal to minus 27.9 and d2y by dx square is equal to 117.6667 at x is equal to 0. Another one is here similarly we have to discuss same problem, but data is different. Data is different. And these are the exercise problem. Do yourself. I hope you are all well understanding. Thank you.